In this video, I'm going to try create a finite state machine based generative art for the fxhackathon 2023. The starting project for this challenge comes with a small circle and some lines which, when we click around on the canvas, moves to wherever we've clicked, showing how code-driven parameters work. Now, I'm not going to need this, but I am going to keep the logic for where we're clicking on the canvas. I'm going to replace that little drawing with a grid of glyphs. Now, the point of this project is going to be the starting state of the glyphs can be changed, and once it's minted, it'll be animated, so the starting state will have a direct impact on how that animation looks. So using the logic for where we're clicking on the canvas and a little bit of extra maths, we can actually work out which glyph it is that we're clicking on. Now, the state of each glyph is going to be stored as a parameter. So the parameter is going to be 100 characters long, each character representing what the starting state of that glyph should be. So as you click on a glyph, I can update that starting state parameter, and then that will allow the project to actually mint the correct tokens. So my first step was getting it so we could toggle between a 0 and a B as we clicked on each glyph. I then added an alphabet of acceptable characters, and we could cycle through that alphabet in the draw function. To make the end result a little bit more interesting, I added a modifier so that the hue of the glyph would change depending on its location in the alphabet. Each frame, a variable is incremented by 1 and then passed into the draw function. This moves each glyph along the alphabet, which is going to create the animation effect. If the variable gets larger than the alphabet length, it resets back to 0 so that the animation will continue repeatedly. We can view the final render by changing the execution context. This is going to call a separate file inside our project, the final.js file, which has a different draw sequence to the minting. When we're in the final.js file, we can't change any of the glyphs, as this is used for the final render, not for the minting context. Each glyph is coloured with HSL colours. I've added some standard parameters so that the user can change the hue and lightness factors. To give collectors a way out of the decision paralysis that parameter projects can sometimes induce, I wanted the randomize function to work correctly. Now, the randomize was a bit of a challenge because the string includes all alphanumeric characters, whereas I only wanted to work with 0 through to 9. And if it wasn't within the range of values for 0 to 9, I would then just convert it to one of them randomly. Now, complete randomness wasn't very satisfying. I decided to go for an approach where I would mirror the left half onto the right half to create a symmetrical theme. This left me with my final problem. The 10x10 grid wasn't producing the most interesting of outputs. I had a look at some of the different formats and found that a 24x24 grid produced enough variety for the outputs to be interesting, but wasn't so large that it made it very difficult for the user to actually configure themselves. The change in grid size meant that I had to change some of the way that the users interacted with the piece. The first thing I wanted to add was a way for them to paint over the piece rather than having to click each glyph individually. I accomplished this by making the click produce a Boolean output of whether the mouse was actually clicked or not, and then as you moved your mouse, it would track whether you had changed to a new glyph, and if you had, it would update it by 1. This meant that you could paint over the canvas, but it wouldn't change the glyphs to a point where it was almost unusable. From my own testing, I also knew that some of the most interesting outputs came from having a blank canvas to begin with. So I added a little shortcut where users could press the C key and it would reset all the glyphs to the blank state so that you could draw from scratch. The final thing I wanted to include was a way to download the output. I achieved this by taking the 10 frames that the output would be and then combining them using GIF-shot library so that it would create a downloadable GIF of the piece. I hope you found something useful in this little journey into my process. The link to this project will be in the description below, and some more information about the hackathon will be there too.